about two other trig ratios. They are called sine and cosine. Now, tangent involved opposite side and adjacent side. Sine involves opposite side and hypotenuse. Cosine involves adjacent side and hypotenuse. So, I have an acronym that we usually use. You'll probably hear me say this a lot. And that will tell you exactly which trig ratio you're going to use depending on the side lengths that you have. SOHCAHTOA. So the SO portion represents sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So that's what SOHCAHTOA means. So in the bottom problems down here, notice the first one says find sine of B. So from B, I'm going to label the sides. The 6 would be opposite, the 8 would be adjacent, the 10 is hypotenuse. From above, when we do SOHCAHTOA, sine uses the opposite and the hypotenuse, which means in this case, I would be using the values of 6 and 10. Reduced, my sine ratio is 3/5. If I want the cosine of B, we don't use opposite and adjacent, we use adjacent and hypotenuse. So adjacent in this case is labeled as 8, hypotenuse is 10, so we have a reduced ratio of 4/5. So what we can do is we can use a sine and cosine ratio to solve for missing variables just like we could with tangent. So in each case, we're only going to find one of the variables in each case. So I'm going to scratch out some of these. We'll scratch out that one, and let's scratch out this one. So in number 6, the first thing you do is circle the angle you're given, and then label the side lengths that you have stuff on. The A is on the opposite side. The 7 is on the hypotenuse. So if we're going to use a ratio, O and H, according to SOHCAHTOA, O and H tell us that we're going to use the sine ratio. So sine of 34 degrees is equal to A over 7. Just like with tangent, depending on where your variable is, this case in the numerator, it will tell you whether you're supposed to multiply or divide. Since the A is in the numerator, we're going to multiply in order to solve for my variable. So again, going to go to the calculator. We're going to say, 7. This time we used the sine ratio, and I believe it was 34 degrees. So we're going to type in 34, and my missing side length in this picture, 3.9. So I'm going to copy that down. A is approximately 3.9. Oops. In the next picture, first thing you want to do, circle the angle, and then label the side lengths. The 5 is the hypotenuse because it's across from the right angle, and the B is your adjacent side because it's next to the angle that I circled. According to SOHCAHTOA, anytime I have A and H, we're going to use cosine. So cosine of 43 degrees is equal to adjacent side over hypotenuse. So B over 5. Again, notice your variable is in the numerator, which means we're going to solve using multiplication. 5 times cosine of 43 degrees. That again is now just a calculator problem. So we go to the calculator, 5 cosine 43 degrees, and we push enter, and it gives me approximately, rounded correctly, 3.7. In the last problem over here, again, the first thing you're going to want to identify is where my angle is, and then label the side lengths that you're given in the problem. The A is your opposite side. Your 10 is your hypotenuse. Anytime I have O and H, we're talking about sine according to SOHCAHTOA. So I do sine of 32 equals opposite over hypotenuse. So in this triangle, A over 10. Again, noticing that the A is in the numerator, so we are going to use multiplication to solve for A. 10 times sine of 32 degrees. So again, we go to our calculator and we type in 10 sine of 32, push enter, and we get approximately, if rounded correctly, 5.3. And that's the missing side that you were being asked for. Okay, so again, previously we had learned that Pythagorean theorem helps us find a missing side of a right triangle, but it has a stipulation that you have to know 2 of the 3 sides. That's not always the case. All of the problems we've talked about in this video, we didn't have all our 2 of the 3 sides. We only had 1 of the sides. So Pythagorean theorem wasn't going to help us in those cases. Special right triangles you can do when you only have one side, but they require that the triangle's angles are 45, 45, 90 or 30, 60, 90. In none of the problems that we talked about in today's video, none of those problems had those specific angles, so special right triangles wouldn't work. So the third way we can find missing lengths in a triangle is using sine, cosine, and tangent, so our trig ratios. Now, all of the stuff we learned about today are specific to right triangles. So you can use trig ratios in any right triangle, and that will help you find the missing parts of the triangle. There's a lot more to this. Notice we skipped the word problems. We're going to spend a whole day talking about word problems and what the meanings say and what the pictures are supposed to look like. We're going to do all that kind of stuff together in class, so don't worry about the word problems. If you can walk away understanding numbers 6, 7, and 8 that we did in the video, and understanding what we did here in 6, 7, and 8, you'll be good to go. If you have any specific questions, make sure that you make note of them so you can ask me about them in class.